Something impossible started happening recently. Gamers with brand new RTX 4090 graphics cards, the most powerful consumer GPU ever made, were posting confused messages in forums. Their systems were underperforming. We're talking performance drops up to 28% in CPU-intensive games verified by independent testing. Nothing had changed. Same hardware, same drivers, same games. Yet somehow, after a routine Windows update, their $2,000 graphics cards were performing like mid-range hardware from years ago. This is the story of how Microsoft's push for security turned into one of the most controversial performance disasters in Windows history. Continue watching to find out exactly what they changed, why it's still affecting gaming performance on millions of machines right now, and most importantly, how to take back control of your own hardware. When Microsoft released Windows 11 version 24H2 in September 2024, the company positioned it as a significant advancement in system security. The marquee feature was memory integrity, also marketed as Hypervisor Protected Code Integrity, or HVCI. According to Microsoft's official documentation, memory integrity is a virtualization-based security technology that creates an isolated virtual environment to verify that all kernel mode drivers and code are properly signed and haven't been tampered with. The system works by running security checks in a protected virtual machine layer that sits above the Windows kernel itself, theoretically making it extremely difficult for malware to bypass verification. Microsoft's security team argued this was necessary to combat the rising threat of kernel-level exploits and rootkits, sophisticated malware that operates at the deepest level of your operating system and can completely compromise your system. The company pointed to real-world attacks that had exploited vulnerable drivers to gain kernel access and positioned memory integrity as a fundamental defense against this entire category of threat. For new installations of Windows 11 on compatible hardware, Microsoft enabled memory integrity by default through a feature called Core Isolation. The stated goal was simple: protect users from the most dangerous types of malware by verifying every piece of kernel-level code before it executes. The technology itself isn't new. Microsoft had introduced virtualization-based security in Windows 10, but 24H2 marked a major shift in deployment strategy, moving from opt-in to default-on for millions of systems. Microsoft's developer documentation explained that the feature requires compatible processors with virtualization extensions and TPM 2.0 security chips, hardware that most computers built after 2018 already have. The pitch was compelling: stronger security with no action required from users. What Microsoft's marketing materials didn't emphasize was the computational cost. Running a hypervisor layer to continuously verify kernel code requires CPU, resources, and those resources have to come from somewhere. The first systematic investigation came from Hardware Unboxed, a well-respected PC hardware testing channel, in October 2024. They ran comprehensive benchmarks comparing Windows 11 24H2 with memory integrity enabled versus disabled across multiple games and different CPU tiers. The results were striking. In CPU-intensive games like Cyberpunk 2077, Microsoft Flight Simulator, and StarCraft II, enabling memory integrity caused measurable frame rate drops. On high-end processors like the Intel Core i9-14900K and AMD Ryzen 9 7950X, the performance penalty ranged from 5 to 8%. But on mid-range CPUs, the Ryzen 5 7600 and Intel Core i5 13400, the drops reached 15 to 28% in certain titles. The German tech publication Computerbase conducted parallel testing and documented similar patterns across dozens of games. They found the worst impacts in competitive multiplayer titles where frame times matter most. One Reddit user detailed their troubleshooting journey that perfectly illustrates the problem. Here's what makes this particularly problematic: the performance impact isn't consistent across all hardware. Systems with older CPUs lacking modern virtualization extensions suffer far more than newer processors with dedicated security hardware. You might think this is just the standard trade-off between security and performance, and users should simply accept slower speeds for better protection. But here's why that logic breaks down. Microsoft never clearly informed users about this trade-off before enabling the feature. When Apple implemented similar security technologies in macOS, they included performance monitoring tools and clear documentation about the costs and benefits. Microsoft's approach was to quietly enable memory integrity on new installations and compatible upgrades, with only a toggle buried in Windows security settings. No notification explaining the change, no performance warning, no prompt asking if you wanted to prioritize security or speed for your specific use case. The performance issues didn't escape the attention of consumer protection advocates and digital rights organizations. While no major regulatory investigations have been formally announced as of early 2025, the situation raises questions about transparency requirements under existing consumer protection frameworks. Several cybersecurity professionals have questioned whether the security benefits justify the performance costs for gaming workloads specifically. The real cost of this issue becomes clear when you consider actual use cases and what users are unknowingly sacrificing. Consider a college student who spent $400 building their first gaming PC around an RTX 4060 Ti and Ryzen 5 7600X. They chose these components specifically to hit 165 frames per second in Valorant because they're trying to improve enough to join their university's esports team, where reaction time gaps of even 15 milliseconds can determine match outcomes. They carefully researched every component, watched benchmark videos, and confirmed their build would deliver the performance they needed within their budget. They assemble everything, install Windows 11 24H2, launch Valorant, and immediately notice something's wrong. Instead of the 165 FPS every benchmark promised, they're getting 115 to 125 FPS, with occasional drops to 95 during intense firefights. The game feels sluggish compared to their teammates' systems. They spend hours troubleshooting, updating GPU drivers, adjusting game settings, checking background processes, and monitoring temperatures. Everything tests normal. They might even spend an additional $200 on faster RAM or a better CPU cooler, chasing performance that should already be there. They never realize that Windows itself is consuming nearly 25% of their CPU for a security feature they didn't know existed and don't actually need for competitive gaming. Think about parents who purchased a $1,100 gaming laptop for their teenager's 16th birthday. They researched carefully, read reviews, and chose a model with an RTX 4050 and Core i5-12500H that every review confirmed could run Fortnite and Minecraft at 90-120 FPS at high settings. Their kid is thrilled. But 2 weeks after purchase, Windows 11 24H2 installs automatically as a part of the laptop's first major update cycle. Suddenly, those same games struggle to maintain 60 FPS, creating a noticeably degraded experience with visible stuttering. These aren't abstract scenarios. These are predictable outcomes when a platform that controls 76% of the gaming PC market makes fundamental changes to system resource allocation without transparent communication. After mounting complaints and negative coverage in tech media throughout October and November 2024, Microsoft did respond. The company published a support document acknowledging that memory integrity could impact performance in some scenarios and provided step-by-step instructions for manually disabling the feature through Windows security settings. Microsoft also stated it would refine the criteria for which systems receive memory integrity enabled by default, focusing on newer hardware with better virtualization support. For systems upgraded from Windows 10 to Windows 11, Microsoft claimed memory integrity would remain disabled by default to avoid surprising existing users with performance changes. But Microsoft's response revealed a fundamental misunderstanding of the actual problem. The company treated this as a communication issue that could be solved with a support document when users needed proactive notification and control. Microsoft never implemented performance monitoring that alerts users when security features are significantly impacting their system. Even more problematic, independent testing in late 2024 found that Microsoft's refinements didn't actually reduce the performance penalty itself. Tech outlets, including PC Gamer and Tom's Hardware, tested systems after Microsoft's adjustments and confirmed that on machines where memory integrity is enabled, the performance cost remains substantial, 5 to 28%, depending on CPU and workload. Here's the security concern that makes this especially frustrating for users who keep memory integrity enabled for its security benefits. That protection is only as strong as their Windows password or PIN. If someone gains access to your system through physical access, credential phishing, or malware that executes before the security features fully initialize, they can simply disable memory integrity through Windows settings. The entire protection scheme can be bypassed by anyone who can boot your system and enter your password. You're potentially sacrificing 20% of your gaming performance for security that a basic 6-digit PIN protects. Compare that to BitLocker Drive encryption, which provides mathematically strong protection even if your device is physically stolen. Memory Integrity's threat model is much narrower, yet its performance cost is much higher. Tech Jesus from Gamers Nexus summarized the situation effectively. Microsoft implemented enterprise-grade security designed for corporate environments where users don't choose their software and IT departments control configurations, then deployed it by default to consumer gaming PCs, where the threat model and performance priorities are completely different. The result is security theater that costs real performance without providing commensurate protection for typical gaming workloads. If you want to take control of your system's performance, here's exactly what you need to do. First, check whether memory integrity is currently enabled on your Windows 11 system. Open the Start menu and search for Windows Security. Click the Windows Security app when it appears. In the Windows Security window, click Device Security in the left sidebar. Then, click Core Isolation Details. You'll see a toggle switch labeled Memory Integrity. If it's switched on and you're experiencing performance issues during gaming, click the toggle to turn it off. Windows will prompt you to restart your computer for the change to take full effect. After rebooting, launch your games and benchmark your performance. Most users see immediate improvement. Second, while you're managing security settings, review other features that might be consuming resources. In Windows Security, navigate to App and Browser Control, then click Exploit Protection Settings at the bottom. This shows various security mitigations applied system-wide and to individual programs. Most of these have minimal performance impact, but if you're on older hardware, you can customize which protections apply to specific games. Only adjust these if you understand the security trade-offs, the default. Settings are reasonable for most users. Third, take control of Windows Update behavior to prevent automatic feature updates from re-enabling settings you've changed or introducing new performance impacts. Go to Settings, then Windows Update, then Advanced Options. Under Additional Options, click Active Hours and set the times when you typically use your computer. This prevents Windows from restarting for updates during gaming sessions. You can also pause updates for up to 5 weeks, which gives the tech community time to identify issues with new updates before they reach your system. When major feature updates like the 24H2 release, consider waiting 2 to 3 weeks before installing them to see if widespread problems emerge. For advanced users comfortable with firmware settings, there's one additional step worth considering. If you've disabled memory integrity and want to ensure Windows cannot re-enable it, you can disable Intel VTX or AMD vVirtualization support in your system's BIOS or UEFI firmware. This is more aggressive and will prevent other virtualization features from working, including Windows Sandbox, WSL2, and virtual machines. So only do this if you're certain you don't need those features. The setting location varies by motherboard manufacturer, but it's typically found under CPU configuration, advanced CPU settings, or security settings in your firmware menu. Disabling hardware virtualization support makes it impossible for memory integrity to function, giving you complete assurance that it won't impact performance. Microsoft made a choice with Windows 11 24H2 to prioritize default security over user transparency and performance. They enabled a feature that consumes up to 28% of CPU resources during gaming, buried the toggle in security settings, and never prominently warned the hundreds of millions of users affected. Your operating system should work for you, not make invisible decisions that degrade the hardware you paid for. Without your knowledge, you have 2 choices right now. First choice, take 5 minutes today, check if memory integrity is enabled on your Windows 11 system, and decide for yourself whether the security benefit is worth the performance cost for how you actually use your computer. Second choice, share this video with someone you know who games on Windows 11, especially if they've complained about performance issues or blamed their hardware. Comment below which option you chose. That accountability matters. And it tells me you're taking control of your system, instead of letting Microsoft make these decisions for you.